Welcome to a new episode of my home automation, OpenHub and Node-RED playlist. I have covered Sonoff smart switches and other ESP devices in earlier videos, and like others, I also noticed response and general connectivity issues. I asked around in a forum, I got some feedback, but nothing awfully convincing. So in this video, I will show you how I monitor them in Node-RED to understand what is happening on my network and hopefully figure out trends and root causes. As always, the link to this example is in the video description. So what you see now is a page on my Node-RED dashboard, which is monitoring 8 devices at the moment. So I originally started with one Sonoff, and I got an H801 RGB controller, which is also based on an ESP8266, and I got 5 additional Sonoffs. Well, actually, that's 6. That's 7 devices altogether, not 8. And I set up this monitoring rig. Most of it pretty much yesterday. So the data that I have here is only like 1 day old, and just now, about like half an hour ago, I made some changes to the script, which means that all these graphs which are here, I got reset, so they basically have almost no data at all. But the graphs, they do have some stuff. So let me explain what I'm doing here. So first of all, some of these devices are on MQTT. So these first 2 devices are on MQTT, and they are sending 2 updates every 5 seconds. One is the uptime, and the other one is the RSSI, which is this wireless signal indicator. And it's not the same as the DBM, which is published, which is usually visible if you have like you want to see the signal strength of the wireless devices on your mobile. That's, I think, in most cases in DBM. So RSSI is a relative measure, and this is probably the most useful article I managed to find on the internet, which basically saying that the closer the value is to 0 is better. So these are negative values, and in general, 50 means it's a good signal. Minus 50 is a good signal, minus 75 is a reasonable signal, minus 90 is bad, and anything below that, like minus 20, would mean that there is no service at all. So looking at the figures I have now, the Sonoff one is sitting behind a couch on the floor, but it's the same room as the wireless router. This RGB one is again on the same room as the wireless router. So this one is probably, I don't know, 6 meters, and that's probably like 4 meters from the router. So and this is what I noticed. So minus 60, minus 70, this is the best that you can get out of Sonoffs. So it's not going to get any better than that. And if you move to another room, it usually drops below minus 70. So even like a simple brick wall will be a significant obstacle to these devices. And then you can see they are jumping around quite a bit. So one easy indication is the signal strength. So obviously, if it gets to much more towards minus 100, then you might be having connectivity issues because the wireless is just too weak. The other thing I'm looking at is the millis. So it's basically the milliseconds since the last update, and since I set the updates to every 5 seconds, these should be around 5,000. So if it jumps anything above like 10,000, 15,000, that would mean that some MQTT messages are lost. And I think my MQTT connection is just with QS0, which means that I think it means that if a message is lost, then it's lost forever. So if this gets jumping around into the multiples of 5,000, that again, that would indicate some issues on the network. And the other thing I'm monitoring here is how much time elapsed since the last update. So if this if I unplug the Sonoff or any of these devices, then the obviously the uptime, the RSSI, and the last millis would just freeze to the last update, but this would just start counting up to, you know, minutes and hours and days. So this is, at least I know that if this is showing anything, you know, more than 5-10 seconds, then it means that the device is not on the network at all. So, and the rest of the devices which are here are, they are not on MQTT at the moment. So what I'm doing is I am calling the web configuration page. So basically I just do http:// and the IP of the device, and I'm checking what the response is. So, you know, normally you expect an HTTP 200, which is an OK, so you get a response back from the server. And that is happening in most of the cases, and that's what you see in dark blue. So, you know, 77 times it's OK, 3 times it's timeout, and then 10 times it's connection reset. And you can see that it varies quite a lot. And these 5 devices, these 5 Sonoffs, are in the same room. They are right next to each other, just a few centimeters apart, which actually could indicate another issue, because this is something I got on the forum, saying that if you have devices close to each other, they might interfere with each other, so that could explain why they are not connected. And I might have noticed the same when I was testing all 5 of them at the same time using the 5 Sonoffs using the stock firmware, and sometimes they just would not connect to the wireless. With ESP Easy, they usually, well, I mean, they do connect to the wireless, but still, you know, Sonoff 6 is reasonably okay. I'm getting response most of the time, a few connection resets, but if you look at the other one, it times out like almost, you know, 45% of the time. So, you know, 43 OKs and 31 timeouts. So it's well, it spreads around quite a lot. And what this graph is supposed to show, it's basically just every time I do a you know, poll, I just plot these values on the graph. So I'm going to come back to this maybe after one day and see how the graph looks like, because at the moment they are just meaningless. By the way, if you don't have Node-RED, you can get the basic stats from the main config page as well. So this is the Wi-Fi RSSI, this is the uptime. So these are the 2 values which I've configured the ESP to push to over MQTT every 5 seconds. And there is other bits and pieces here, like, you know, memory size. And the funny thing is that even if I notice some issues with the ESP, there's usually nothing here which would indicate any problem. Like, you know, the load is really, it's always low. The memory size is, there is always some free memory. I don't know whether this should be an indication or not, but again, I usually not seeing anything here which would stand, you know, which would be an extraordinary values. So just to show the configuration for the uptime and the Wi-Fi. So you come to devices, and then you'd edit the uptime. Edit the device or add the device. So I use this for the uptime. So the device type is sysinfo. The name is uptime. The indicator is uptime. You tick send data. I take away the decimals, and you set the index. Just to make sure that, so this variable ID needs to be unique for all the items here. So 1, 2, 3, and for the sysinfo, it's for the Wi-Fi, it's pretty much the same. So the device is system info, the name is Wi-Fi, the indicator is the Wi-Fi RSSI, and send data again, no decimals. And I think the last thing you need to do is actually here, which is the sensor delay. So 5 means that it sends a message in every 5 seconds. By the way, when it comes to monitoring, and if you want to monitor anything locally on the device, you can come here to the log as well to see if anything is happening here. And if you go back to, Tools, Advanced, and if you set the web log level to 4, that's the highest the log level, this is where you see most of the logs here. And at the moment, it's the usual stuff. It's the MQTT messages that are being sent out are logged here, and you can see these jumps here on the screen that sometimes I'm losing connection to this device as well. So even this one being sort of alone in the room, there are no other wireless devices around it, and I'm still getting these intermittent connection issues. So how does it look like in Node-RED? I've created this separate tab like ESP signal, and I have this group which is monitoring one single sensor, and so I'm looking at I'm hooking onto the MQTT and looking at two different topics. The one is the device name / uptime and the device name / Wi-Fi. So this is where the uptime comes through. And if I turn on the, I don't have a debug here. So if the uptime comes in, all I'm doing is I'm saving this uptime in a global variable. And yeah, so device name is Sonoff, and then I save it in Sonoff _uptime. And I'm also displaying a message on the the status here. So for any functions, I can see I can set the status, which comes on in the editor as well. So I can see the current uptime here as well in the editor instead of, so I don't have to open up the dashboard just to see that piece of information. So this is what is being printed here. And this piece of logic here, it checks whether the current uptime is great or actually less than the previous uptime. And that would usually happen if the device got restarted, because let's say if I restart this one, now the current uptime is 28599, and then when I plug it back again, it will be 0. So then I know that the device got restarted, and this is what I'm handling here. I'm setting some variables, and first of all, I'm just printing the uptime to the screen. And also here, if I have this sort of warning set here, then I send out a message saying that the device has been restarted. And I implemented this in also in the dashboard. So I have this separate tab for logs, which I use for the display various logs from the application. And I can see that I got the RGB got restarted, and well, you can see the previous and the current uptime value. So it was running for 51 minutes, and then it got restarted, and then previously it was running for like 1.5 hours, and then it got restarted, and you get a timestamp. So again, it's just more like monitoring for me. So I know if there was a power outage or something, at least I get a notification when the Sonoff got restarted, or when the ESP got restarted, sorry. Okay, and then on the gauge stuff, it's again pretty much the same. So the message from the MQTT goes into the gauge, and I have a small function which again, all it does, it saves the timestamp whenever we get a message, and then when I receive a message next time, I get this timestamp, which was the timestamp from the previous one, and I extract it from the current time. So this get time always gives me the milliseconds, and this is how I get the millisecond passed since the last update thing. And this part of the screen here is again just formatting dates and times, and displaying the information here in the editor and also in the dashboard. So again, I don't have to open the dashboard just to look at this. And this piece, the final line, is just doing the last update. So again, it's just more math, date calculation, and this part is just printing of the date difference and formatting into seconds and minutes and hours and days. So this block is responsible for one single device, Sonoff 1 in my example, and this next block is responsible for the other device, which is the RGB or the H801 module, and it does exactly the same thing. So I just copy and paste this block, and all I'm doing is I'm changing the device name. So the device name here, and the actually I haven't done the device name here, but you need to check these variables. So every time where there is a global set or a global get, just update them to the actual device name, and the same applies to here. So there is a global set here, and global get here, and that's pretty much it. So you can copy and paste these blocks as many times as you want. Just always update the globals, and of course update the the MQTT subscriptions here. And yeah, that's all fine. Yeah, these are not device dependent codes which are here. And the last this piece here is responsible for all these charts and the graphs, and for some reason it's not working for this RGB controller, but it's working for all the Sonoff devices. And sorry, not this window. And so I have an inject which executes every 10 minutes, and then it does an HTTP request, which is usually the HTTP:// and the device IP. And then it goes to a result calculator, which creates this object and stores it in a global variable. So again, if you're copy and pasting the code, there is a global get here and a global set here. And so at the moment I'm looking for I'm distinguishing OKs, connection resets, not found, which would be like if the device is not available, not connected, and timed out, and any other error messages. And all I'm doing in this switch case is looking for these error codes and just incrementing some counters, and based on this result I'm updating the charts every single time. So every time there is an update, I'm sending out 5 series to say that the OK messages and how many OK messages, connection resets, and number of connection resets. And the only reason I had to do this because where is my chart? Yeah. So when you push something for a chart, it can understand different value series by the topic, but the way the color is assigned is based on what's the first topic which comes to the chart as a message. So I needed a way to make sure that the value series in all the charts are the same, because otherwise the dark blue here would be okay for Sonoff 2, but it could be connection reset for Sonoff 3, and it would be really difficult to understand the values. So anyway, this is how it works, and then the information goes into both the charts and the pie chart and the the legend. And exactly the same happening for all the other devices. So just update the IP here, and in the code again update the global set and the global get, and it is going to work. And on the on the editor side, I've added a full reset as well. So if you want to reset all the values and reset all the charts, you click this inject manually, and it will just do that. If you want a slightly bit more information or you want to follow up this topic, this is that's the topic I opened in the ESP Easy forum. And I started with the same issues that I explained at the beginning. That, but just by looking at the status page, I couldn't really tell if something was wrong with my ESP, and hence I started this whole discussion on the this whole exercise in Node-RED to somehow monitor it and then draw some conclusions. And then one of the comments here was saying that if you have a lot of them at the same place, then that could be interfering with each other. And if I remember correctly, somebody was saying that to keep them alive, they used to, so he usually sets up a ping, which pings the devices every 15 minutes or 10 minutes. And I was hoping to do the same by doing these web monitoring, because it just forces the ESP to keep the, I don't know, HTTP server running or something like that. So anyway, we'll see how it works. So if you want to follow up on this, go to this topic. I put the link to the video description. Almost a day has passed since the previous clip, and after that I just reset the stats, and it's been running basically overnight and this morning. So you can see that again the data varies quite a bit. So I have two Sonoff devices which are acting really nice. So like you see 124 OKs, and then basically there was one connection reset in the last 12 hours, and pretty much the same here, slightly bit more connection reset. And that's how the graph looks like. So you should be looking for these blue one rising steadily, which means that every 10 minutes we are incrementing the OK responses, and anytime when it is like flattens out a bit, that means that there was some issues. Again, I'm not sure if this is the correct way of representing this, but once you understand how the graph works, then I think it's good enough. And you can see, just like yesterday, this Sonoff 4 is acting up for whatever reason, and you can see that okay, we had some good response in the beginning, and then it was from like 6 o'clock all the way to 1 a.m. It was pretty much flat. There was not a single response in that sort of like 6-hour window, and it started responding, and there was a like an off again, and it's going up again. So and I mean, for me, it's pretty hard to explain why this is happening. And it seems that most of the issues here are like the other errors, which I haven't classified. Maybe I should go into details of that. So it was mostly other errors in overnight, in the evening, and then the timeout started to pick up as well. So it's a nice report, but again, I'm still struggling to find out the root cause of that, and I can just play around by moving the Sonoffs. As I said, 2 to 6, so these group of 5 are really close to each other, so it could be an interference issue. And going back to this RGB ESP, I plugged it off, and as I said, the uptime and these the 3 top figures just freeze in time, and this is why I added this last one. So it's now counting up. It's been offline for the last 16 hours. So I think that's all there is to it. This is my take on sort of like ESP signal monitoring. I hope you find it useful. Again, go to the video description to find a link to this particular flow in Node-RED. If you want to implement something like this, feel free to use and then reuse it. Thanks for watching, and see you in the next episode.